Hi, good evening. In this lecture, I will continue with quadratic models. I will go ahead and quickly discuss what we did in the previous lecture, and then I would start with the new quadratic model. Now, to begin with, in our previous lecture, we talked about completing the square method. What is completing the square method? For example, if I want to find out what is a plus b whole square, this is a square plus b square plus 2ab. On very similar grounds, if I ask you what is x plus n whole square, where n is a constant, it can be any constant, and x is a variable. This is not even required, right? You can just assume x plus n whole square. You will say it is x square plus n square plus 2ab. Plus 2xn. Now, usually, in any modeling that we do, in any quadratic equation, that would be given to you, we would not have this part given to us. This would not be there. Okay. In this aspect, 2xn, you would be given something. This would be present. From this 2xn, you will go ahead and find the value of n. Once you find the value of n, you can find what will be n square. You will add this n square here. But because you are adding something to an equation where it was not there, you will also subtract it from there. So what you will do is, step 1, you will find the value of n. Step 2, you will add and subtract n squared. So your equation will become whatever your given equation is. You will add n squared to it and you will subtract n squared from it. Once you have this n squared into equation, you will rewrite this part as x plus n whole square. Okay, so this is what is completing the square method. You have completed the square and you will have this n squared left and some constant left here. This is how we will complete the squares. Now we want to take an example and see how we do it in the real world. So I will start with this example once. Let's see this example one more time. Minus 2x squared plus 40x minus 600. So the function that is given to me is minus 2x squared plus 40x minus 600. Now, this is a constant. This doesn't have any x term in it. So you will keep this aside. You will not even think about this term. From the remaining term, I want to just take 2 common and write this as x squared minus 20x. This constant is aside. I don't want to think of this constant at all. Now, do the first step. What was the first step? You will go ahead and find n. How will you find n? You will equate this part to 2xn. So you will say 2xn is equal to minus 20x. Once you do that, you will get the value of n. So n will come as minus 10. If n is minus 10, n square will be 100. Okay, so you have performed the first step. You have found out the value of n. The second step is you have found out what is n square. Now you will add and subtract n square. So within this bracket, I will go ahead and say minus 2 x square minus 20x minus plus n square minus n square minus 600. Now just see this. If I have added and subtracted 100 from the equation is unchanged. Nothing has happened to the equation, right? It's the same. This can still cancel out each other and I will be still left up with the initial equation. So nothing changes in that sense. Now what I will do is the following. I know that if I look at just this aspect, just this part, then isn't this x plus n whole square, where n is minus 10. So isn't this x minus 10 whole square, right? You can open it and see it. So x minus 10 whole square will be x square, a square plus b square minus 2ab. So this will be getting multiplied. So this will be x square plus 100 minus 20x. Just compare it with this one. It's the same thing. So instead of this term right here, instead of this term, I will go ahead and write x minus 10 whole square. This is completing the square method. So what I will do is, instead of this term, let me go ahead and write minus 2 x minus 10 whole square minus 100 minus 600. Minus 600, right? Yes. Now let's open this bracket. So I will get minus 2 x minus 10 whole square plus 200 minus 600. If I solve for this, I will get minus 2 x minus 10 whole square minus 400. Now, please understand what we just did and why is this important. I started with an equation which was this. From this equation, unless I don't differentiate the function, it is very difficult for me to know where is the where is the vertex of my parabola. And it's very difficult to understand at which point is my parabola attaining its minima. What is the position of my parabola? What is the slope of my parabola? What is the way that my parabola looks? I cannot answer anything from this function. But the moment I have written down this same function, after completing the square method in this format, now it is very easy for me to understand what the function looks like. So let's look here. Now, there are two things that can happen from here. One, x is equal to 10. That's the first thing that can happen. Either the value of x is 10. Second thing that can happen is x is anything but not 10. It can be minus 4, minus 100, minus 50, 50, 500, whatever, but not 10. If x is 10, just see this, I will put minus 2, 10 minus 10 whole square minus 400. So I will get the answer as minus 2, 0, minus 400. I will get the answer as minus 400. So if x is 10, then the answer that I am getting is minus 400. Right? If x is not equal to 10, maybe minus 1, maybe 0.5, maybe minus 0.5, whatever you want to put. If x is not equal to 10, supposedly x is 0. Then 0 minus 10 whole square minus 2 minus 400. This will be minus 2 This will always be positive. Minus 10 whole square is 100. Minus 400. This will be minus 600. Right? Suppose x is 1. Suppose x is 1. Then 1 minus 10 whole square is minus 9 whole square. Minus 9 whole square is 81. Suppose x is minus 1. Minus 1 minus 10 minus 11 whole square is 121. So, what I am trying to explain to you is that whatever comes as value of x, as long as it is not equal to 10, then that value of x square, x minus 10 whole square, this part will always be positive because it is getting squared up. And if it is positive, getting multiplied by a negative sign, then this entire thing becomes negative. And negative minus 400 will give you a bigger negative value. This is fine. Now it's simple. That, what? When x is 10, then I achieve minus 400. So when x is 10, supposedly here is some minus 400, I achieve that. But for value of x which is not equal to 10, anything below 10 or above 10, I receive something which is even more negative. Maybe minus 500, minus 700, minus 200, minus 450, whatever. I receive a negative number which is more than minus 400. So, I receive a value which can be below minus 400, somewhere over here. This is the minimum value of x possible. At x is equal to 10, I'm getting the minimum value of y, which is minus 400. And for any other value of x, I go below minus 400. I go even more negative. So my parabola is like this. My parabola has achieved its minimum value its maximum value at x is equal to 10. And whenever x is not equal to 10, the value of y is more negative. Right? So now let's go back and see what was the one feature that was happening here, which did not happen anywhere else. And that feature actually is that in this example, A was negative. A was negative. What was A? The coefficient that was coming with x, that was negative. Now let's go back to the exam, to the different graphs that we had. So I'll quickly go up here. So you see this, when A is negative, you always achieve a maxima. And the parabola is always shaped like this. And this is exactly the shape that we achieved. We achieved the shape which is like this. So completing the square method actually helps you to achieve the maxima or minima of the function. Now, I would like you to take all these examples once and try them again and see what happens in different cases. Now, let's go ahead with the following question. Now, this is something that we have discussed in detail in the last class. Today, I want to go ahead and I want to go to the quadratic optimization problems in economics. So I want to talk about how I can use my optimization techniques in economics. To understand that, what I'm going to do is I'm going to take this example So I'm saying that the price is given as 102 minus 2Q. And I'm saying that the cost of producing and selling Q units is given as this. Right? So, we understand that whenever we have to calculate the profit of the firm is price into quantity. This is the revenue minus the cost. So revenue minus cost gives me profit of the firm. This is something which we will do in another few lectures in microeconomics also, where we try and understand that the profit of the firm is revenue minus cost, and the revenue is price into quantity. So if I'm given that the price is 102 minus 2Q, what do you think will be the revenue? Revenue will be price into quantity, which will be 102 minus 2Q into Q, which will be 102Q minus 2Q square. This is the revenue. What is the cost? Cost is given as 2Q plus half Q square. So revenue minus cost this is the profit of the firm. Now, any firm would always aim at maximizing their profit. So ideally, the aim of the firm is to maximize their profit. And how do you think that the firm can maximize their profit? Well, we know that to maximize the profits, we must differentiate the profit function with respect to quantity. Because ultimately in this function, I can only determine the quantity. Only Q is the variable that I have to determine. So if I differentiate this function, what do I get? Differentiation of 102Q is 102. Differentiation of minus 2Q square is minus 4Q. Differentiation of minus 2Q is minus 2. And differentiation of half Q square is minus half into 2Q. Whenever we maximize or minimize any function, we equate it to 0. So let's do that. 102 minus 4Q minus 2 minus Q is equal to 0. 100 is equal to 5Q. Q is equal to 100 by 5, which is 20. So we have gone ahead and have been able to find the optimal quantity. Now, once I have found out what the optimal quantity is, I can put back this Q in my price and get the price. So Q is 20. Put this 20 in the price function once. So what will you get? P is 102 minus 2Q. Q is 20. So P will be 102 minus 2 into 20, which would be 102 minus 40, which will be 62. This is the price. What will be the cost? Cost will be 2 into 20 plus half into 20 square is 400. So this will be 40 plus 200. This will be 240. So what is my cost coming as? Cost is coming as 240. What is my price coming as? Price is coming as 62. What is my quantity coming as? Quantity is coming as 20. So what is my profit? Profit is revenue minus cost, which is price into quantity minus cost. So 62 into 20 minus 240. So this will be 1240 minus 240, which will be 1000. So the maximum profit that I can make, maximum profit, why maximum? Because I'm talking about the maximum quantity. So the maximum profit that I can make will be 1000. Now, let's take another example. So this is, consider a monopoly. Now, the cost function of monopoly is given as alpha q plus beta q square, and the price function is given as a minus bq. Now, not now, but once we start doing monopoly in microeconomics, I will tell you how monopoly is different from perfect competition. We will thoroughly discuss this, that a perfect competition is a price taker. It takes price as given. Because a perfect competition is a price taker, usually it sets price is equal to marginal cost. Price is not above the cost of the firm. Ideally, we say that it's a no profit, no loss situation. Whereas a monopoly actually makes profits. And again, we will discuss and we will show how, and actually this is equal to AR, this is equal to MR. But here I will show how MR and AR are different. So we'll do all of that as part of microeconomics. But what is it in there for us as part of maths is to notice that the cost function that I draw, irrespective of the kind of firms, we end up drawing cost functions which are quadratic cost functions. So this is the cost function that is given to me. This is the price that is given to me. If I ask you what would be the equilibrium quantity, you will go ahead and tell me that the equilibrium is attained such that your profit is equal to, you're maximizing your profit. So price into quantity is your revenue minus cost, and you want to maximize this. So price is A minus BQ, quantity is Q, cost is alpha Q plus beta Q square. So this gives you AQ minus BQ square minus alpha Q minus beta Q square. Now I want to maximize this. So I will say del pi by del Q is equated to 0. Differentiate this function, what will you get? You will get A minus 2BQ minus alpha minus 2 beta Q is equal to 0. Solve it. What will you get? You will get A minus alpha is equal to 2B plus 2 beta into Q. Find out Q star. What would that be? Q star will be A minus alpha upon 2 B plus beta. This will be the optimal quantity. Just imagine this. I have a revenue function in monopoly, something like this, right? We'll take it in micro, don't worry. But I have this revenue function, and then I have this, and here ideally I have a linear revenue function or a quadratic, right? So you see this is my revenue function, AQ minus BQ square. So this is quadratic. So I have a quadratic revenue function and I have a quadratic cost function. So that is why we'll have changing slopes. Because what is quadratic? When the slope changes from increasing to decreasing or decreasing to increasing. So I have a revenue function to play with, and then I have a cost function. So let's let's say that I'll draw this as my revenue function, quadratic, and I want to draw a cost function. Okay. Ideally, I'm going ahead and I'm actually changing my slope thrice, if you notice in the cost function, because very shortly I'll show you how cubic functions work. But for now, you can just imagine, if you notice, this is increasing, decreasing, and increasing. So ideally, I'm changing the slope thrice instead of twice. So, that becomes a cubic function. So what I can do is, for simplicity, I will just assume that this is my cost function. Or if you want, if you still want to draw it quadratic, you can maybe just have a cost function like this. That's it. But now understand what is happening. Profit is the difference between revenue and cost, right? This is my profit. And I'm trying to maximize this profit. And in order to maximize revenue minus cost, I am, this is my revenue minus cost. I am saying, how do I maximize this function? I differentiate my profit function with respect to quantity and I equate it to 0. Whatever Q I am getting from here, that is what is maximizing my profit. Isn't that the case? Now, if I go ahead and I differentiate this function, profit function with respect to quantity, it's like saying I'm differentiating total revenue with respect to quantity minus total cost with respect to quantity. This is what I'm doing. Now, this term right here, when you differentiate TR with respect to Q, this term here, this is known as marginal revenue. And this term right here, when you differentiate cost with respect to quantity, this is called marginal cost. And now I'm saying, after I differentiate, what do? I equate it to 0. This means that marginal revenue is equal to marginal cost at the point of my optima output. What does that mean? It means that, and I just told you that MR is when you differentiate TR with respect to Q. So ideally, your marginal revenue is the slope of the total revenue. Marginal cost is slope of total cost. And we are saying that when do I achieve my equilibrium? I achieve my equilibrium where MR is equal to MC. So if MR is equal to MC, ideally I am saying that the slopes are equal. If the slopes are equal, I am actually saying that I will get parallel tangencies. If I draw a parallel, if I draw a line, if I draw a tangent line of TR and I draw a tangency of TC, wherever my optima output exists, those tangent lines should be parallel to each other because the slopes of the two curves are equal, because that is what my equation just mentioned, that the slopes are equated to 0. Difference between slopes, so the slopes are equal to each other. So ideally, what has really happened here is that whenever I'm trying to maximize the profit, profit is revenue minus cost. Maximizing profits means differentiating the profit and equating it to 0. But that means equating their slopes. And that means that if I draw a tangent line through these two curves of total revenue and total cost, the tangent lines or the slopes should be equal to each other or parallel lines should be there. Now, let's go ahead and check further what has happened. So I have gone ahead and I have been able to find my optima quantity. And based on that, I have also been, And based on that, I have also been able to find my profit. Profit is simple, we know. I just have to multiply price into quantity minus cost, and I will get my profit. Now, this is the optima quantity of monopoly. We are clear with this much. Now let's go ahead and check the validity of quantity. See, in the numerator, I see that I have A minus alpha. Okay. If A is greater than alpha, then the numerator is positive. Then I have some quantity which I am producing. But if A is less than alpha, then in that case, my numerator, or maybe equal to alpha also, my numerator is less than equal to 0. And if my numerator is less than equal to 0, then in that case, my quantity optima would be 0. I don't want to produce in that case. Now let's try and check what does this mean graphically. Just think about it once. What happens when your numerator is negative and you don't want to produce any quantity? Well, this would mean that, you are on those sides where your cost is more than revenue. Just go back to the same diagram once and look at this aspect. Look here. Or look at this aspect. What is happening here? Here, my cost is more than my revenue. Here also, my cost is more than revenue, which means I'm making negative profits. In case of negative profits, will I produce? No, my quantity will be 0. So I don't want my profits to be negative. And now if I look at my profit function also, that also has the same A minus alpha. So if A is less than alpha, then my profits are negative, which means my revenue is less, cost is more, and in such cases, I will not do any production. Okay. Now, this is only valid if A is greater than alpha. And, if A is less than alpha, then firm will not incur any production. It will not do production. Then the quantity would be 0. And the profits will obviously be 0. It's better to have 0 profits than negative profits. Always remember, right? Now, I kind of want to also focus a bit on the profit function of the firm. So, this is my profit and this is my quantity. Ideally, what is happening is as I increase my quantity, my profits start increasing. There is a point where my profits are maximum, but post that my profits start decreasing. And these are these 2 points where my profits are actually 0, which means my TR is equal to TC. And below this, actually, my profits are negative, where I don't want to be ever. It's better to have 0 profits than to have negative, right? So if I have to look here on the same diagram, then look here. See, this is certain quantity. As I keep on increasing my quantity, the gap between TR and TC is increasing. Revenue increases further, the gap between TR and TC keeps increasing. So my profits are increasing. Here, my gap between TR and TC is maximum. And then the gap starts decreasing between TR and TC. At this point right here, TR is equal to TC, so my profits are 0. even at this point, TR and TC are intersecting. So my profits are 0. Right? Okay. So this is all about a profit function of monopoly. Now, once we have got this profit function, we want to go ahead and we want to also suggest what happens if A is less than alpha. If A is less than alpha, we will actually have negative profits. And if I have negative profits, my best aim or my best chance is to have 0 quantity and not produce at all. Okay. Now, here is the deal. Supposedly, I want to go ahead and shift from monopoly to perfect competition. Now, one thing that I just mentioned to you about perfect competition is like, unlike monopoly, where the monopoly decides the price depending on how much it wants to sell in the market, and the profit price function is A minus BQ. As it wants to sell more, it will keep reducing the price. Unlike this scenario, a perfectly competitive firm is a price taker. So a perfectly competitive firm will take the price as given. And it will take some constant number. So it cannot vary this price depending on what quantity it wants to sell. Irrespective of whatever quantity it wants to sell, it will always have the same price. Okay. So for a perfectly competitive firm, if we want to shift from monopoly to perfectly competitive firm, what do? We should not have this component at all. And we will not have this component if and only if my B is 0. Then there will be no relation between P and Q because B is 0. So what I go ahead and I do is, I say let B be 0. Which means I'm trying to see what happens in a perfectly competitive firm. So I say let B be 0. If B is 0, my price comes out to be A minus 0 into Q, which comes out to be A for all Qs, for all value of quantity. So irrespective of what my quantity is, my price is held at A. Now, given this price, if I now ask you, what is the optima that you will achieve? Well, it's very simple. Your optima will be profit maximization. Profit will be maximized at PQ minus cost. Price is now A. Quantity remains Q. Cost, as we know, is this alpha Q plus beta Q square. So your cost is alpha Q plus beta Q square. So if you have to maximize your profit with respect to quantity, you will get A minus alpha minus 2 beta Q is equal to 0. So you will get your Q star as A minus alpha by 2 beta. This will be your quantity. Right? So that is what I'm going to do. If we solve here, then you will get A minus alpha by 2 beta. This is what we've got, right? A minus alpha by 2 beta. You can also replace A by P because that is what was the initial case. The value of P was A. So you can also replace A by P and you will get your Q star as P minus alpha by 2 beta. This will be your value of Q star. Let's just check this out. You know, if you solve for a perfectly competitive firm, you will get your optima as P minus alpha by 2 beta. And accordingly, if you solve for the prices, you will get your price as a P minus alpha by 4 beta. There is another way to get these values. What? You have already found out for your monopoly, right? This is the values that you're getting for monopoly. Now, all that you have to do from here is put A is equal to price, because the price is equal to A, and put B is equal to 0, because that is what we just found out. Similarly, put B is equal to 0 and A is equal to P, and that would be the case of perfectly competitive firm. So perfectly competitive firm has B 0, and therefore its P is equal to A. That is what we just did. So now if you go ahead and you solve for it, this is the quantity that you will get and the price that you will get. You will be willing to sell quantity only if price is greater than alpha. If price is less than alpha, then nobody works at negative profit, even from here, even from here. So if price is less than alpha, then your optima quantity becomes 0. Okay. So, you know, this is what we have got, that P is less than alpha, then optima quantity is 0 and the profits are also 0. Even at equal to alpha, this is the case. Now, what we have got is the following, that we have been able to get Q star in terms of P for a perfectly competitive firm. If I solve this for the value of P, then I will get something like this. This is, so you know, from here, you have your Q star is equal to P minus alpha by 2 beta. You just got this. If you solve for B, which will be alpha plus 2 beta Q star, we're just taking this here, adding alpha and getting P. If you solve this for the value of B, this is called the supply curve of the firm. Very, very important. Definitely people ask you, derive the supply curve of the firm. So this is how we are deriving the supply curve of the firm. Very simple. We found out what is the price of perfectly competitive firm, what is the quantity of perfectly competitive firm. For that P and Q function, we put those in the profit function, we maximize the profits. We got an optima Q star in as a function of P. We rewrote that function and we got P as a function of Q star. And this is known as the supply curve of the firm. So, you know, this is called the supply curve of the firm, and it only exists given that P is greater than alpha. So actually, I can write that the supply curve of this firm will be P is equal to alpha plus 2 beta Q star if P is greater than equal to alpha, and you know, if P is less than, you're not even greater than equal to, actually greater than alpha, right? Only if P is greater than alpha, you were getting optima Q star, and we know that if P is less than or equal to alpha, your optima quantity was becoming 0 because your profits were negative. So you don't want to sell anything. So your optima was 0. And if I replace this Q star by 0, I get alpha plus 0, which means I get just alpha. So, I simply get P is equal to alpha if P is less than equal to alpha. Or actually, if P is less than alpha, whatever value I'm getting. So ideally, my Q star just goes off. It becomes 0 if P is less than alpha or equal to alpha. So this becomes the supply curve of my firm. Now, here you can just write in fact P equal to alpha. Okay. Now, how do we plot the supply curve of the firm? Very simple. So for all values of P between 0 and alpha, my quantity is 0. Q star is 0 if P is less than equal to alpha. Right? The moment P exceeds alpha, then I have a positively sloped supply curve of the firm. The intercept is alpha. We know, we have studied linear functions. So this is the intercept. And the slope is 2 beta. So we are able to fetch the intercept and the slope of this curve from here. Now, once we have got this, we want to do one final task here. So we were able to get perfectly competitive firms output. We were able to get monopolies equilibrium. But now, if you compare the two, you will notice that the price that exists in monopoly is greater than the price of perfectly competitive firm, and the equilibrium quantity of monopoly is less than the equilibrium quantity of a perfectly competitive firm. So you will notice that actually a monopoly sells lesser than competitive firm and it sells at a higher price. Now, supposedly, as a government, I want that, monopoly should increase its output. Then I have to do something to initiate this increase in output. Either, through taxation or subsidy. Well, whenever you are willing to, whenever you want firms to increase the output, you give firms different amount of subsidies. So for example, let's talk about these zones, okay? Special economic zones, SEZs. When we create these special economic zones, we want firms to produce a lot in these zones because these are backward zones, right? So to kind of promote the firms to come here and establish themselves, we go ahead and give these firms free, not free actually, subsidized electricity. Electricity at a very low price, water at a very low price. So now, from our analysis, we have seen that a monopoly's equilibrium quantity was coming as, let's just go back and check, but it was coming as, I think so, A minus alpha upon B plus beta, something like that. Let's just quickly see this. So it was coming as A minus alpha upon 2B minus beta. So monopoly's quantity was coming as A minus alpha upon 2B minus beta. And the quantity of a perfectly competitive firm was coming as A upon A minus alpha upon 2 beta. And I'm telling you that A minus alpha upon 2 beta is definitely greater than A minus alpha upon 2B minus beta. And this is something you can check for yourself. So just notice here, numerators are the same, 2 is the same. This is beta. This is B minus beta, right? So B is less than B minus beta if 2 beta is less than B, if beta is less than B, or B is greater than beta. And B has to be greater than beta for quantity to be a positive number. So this is given to us that B is greater than beta. If B is greater than beta, then we are, B by 2. This is given to us that B is greater than 2 beta. So, this is something I'm going to assume that this is true. So given that B is greater than 2 beta, I'm going to go ahead and suggest that the equilibrium quantity of the monopoly is less than equilibrium quantity of perfectly competitive firm. Is this fine? Now, following question arises. If I want to somehow ask the monopoly to produce the same amount as a perfectly competitive firm, what should I do? How can I go ahead and ask the monopoly to produce same as perfectly competitive firm? Now, let's go ahead and see. If I want that to happen, I want to first check the following. The demand curve is given as A minus BQ. This is the demand curve. The supply curve of the firm is something we just found out, alpha plus 2 beta Q. If I have to solve for what happens in the market, I'm going to equate the demand in the market to the supply in the market. And by equating demand equal to supply, I'm going to get some price and some quantity in the market. So when I equate demand to supply, we get this equilibrium quantity. And the equilibrium quantity that I have got is this: A minus alpha upon B plus 2 beta. And the equilibrium price that I have got is this: 2A beta plus alpha B upon B plus 2 beta. And the equilibrium profits that I have got are these. Okay. Fine. So, I just want to stop here for today. And I will go ahead and take this from here tomorrow. So please understand what all we have done today. We started by finding the profits for a monopoly. We compared this to perfectly competitive firm. We found out the supply curve of any one firm. And then we equated supply to demand and we found out the equilibrium. Tomorrow, I will try and compare this and I will see what is the amount of subsidies that should be given to a monopoly. Thank you.